All right, so 512 more trig identities. This is the first three of the cofunction identities. The others are on the formula sheet. So cofunction identities are basically based on complementary angles. So you can switch between sine or cosine by using the complementary angle. Complementary add up to 90 degrees. So for example, if we use 30 degrees plus 60 degrees equal 90 degrees, or we could use radians. But I know you guys do better with degrees, so I'm doing this in degrees. So if I had the cosine of 30 degrees, and I look at the unit circle, I see the value of cosine of 30 degrees is square root 3 over 2. Okay, and if I look at the sine of its complement, so this one's 30 degrees, cosine of 30 degrees, and the sine of 60 degrees. So if I look at the unit circle, sine of 60 degrees is square root 3 over 2. So the cosine and the sine of complementary angles are equivalent. They're the same. And that's pretty much what it's telling you here. Sine of an angle is equal to the cosine of its complement. Like pi over 2 is the same as 90 degrees, right? So whatever angle this is, the sine of this angle is equal to the cosine of 90 minus that angle, which is what I just did here. Cosine of 30 is equal to the sine of 90 minus 30, which is 60. And they're the same. Does that make sense? So cosine of an angle, if I say cosine of 30 degrees, is equal to sine of 90 degrees minus that angle, 30 degrees. 90 minus 30 is 60. Saying cosine of 30 is equal to sine of 60. Cosine of 30 is equal to sine of 60. It's true. And you could do that with the unit circle on your formula sheet. You could look at any of the values that are complementary. If the angles add up to equal 90 degrees, their values are going to be the same for sine and cosine. And tangent and cotangent work that way too. And then there's the other three cofunction formulas on your formula sheet also. So an example of a problem like this. Example, if tangent x equals 0.69, then cotangent of pi over 2 minus x equals what? Tangent x equals 0.69. Then cotangent of pi over 2 minus x equals what? So if this is talking about tangent, and we can see this should stand out as being cofunction. Pi over 2 minus something. If you look at your formula sheet, you see it's pi over 2 minus something. Okay, so that matches. And on the left is tangent. So if tangent x equals cotangent of pi over 2 minus that, and tangent x is 0.69, then what is the right side? It is 0.69, you're right. They're the same. It's saying that tangent is equal to cotangent of pi over 2 minus theta. So if tangent is 0.69, the left side 0.69, and then the cotangent of this equals what? Well, cotangent of that is equal to tangent x. Tangent x is 0.69, so is that. Not that bad, right? See? I tell you. Okay. All right, that's cofunction. And you can tell Because normally you'll see a pi over 2 minus a theta, and then go to that section of your formula sheet. Not every problem is exactly the same, but there's one type. Yes.
Then why are we talking about them being complementary if they're the same?
Tangent of an angle is equal to the cotangent of its complement.
Okay, but the angle is different. So
Yeah, the angle, but you weren't asked for the angle.
yeah.
You were just given the value. All right, odd even identities. All right. Again, I'm only going to put the first 3. There are some more on your formula sheet, but I'm just going to, they all work the same. Sine of a negative angle theta is equal to negative sine of the positive angle theta. B. Cosine of negative angle theta is equal to cosine of positive angle theta. Of its positive. Can't talk today. And then the third one I'm going to do is tangent. Tangent of negative angle theta is equal to negative tangent of positive angle theta. All right, so this section is called odd and even identities. That has to do with the function. Is it an odd function or even function? Way back in like September, we did odd and even functions, and it was very tempting to just look at the power of the degree to tell you if it was odd or even. But that wouldn't help you with these, would it? It's fine for polynomial functions most of the time, not all of the time. It's just not a reliable test. The test that I showed you and told you to use to figure out if it was an odd or even function was, is it symmetric or about the y-axis? So we need to look at the graph of the sine function to determine if it's odd or even. So remember to graph sine, we use Sahala. Sine was axis, high, axis, low, axis. But since I'm looking at the y-axis, I need to extend it to the left a little bit. So it ends here, and then that way I can do my graph. Which that's more than of the graph than I really need. Because if I'm determining if it's odd or even, I'm just looking at what's happening at the y-axis. At the y, so just here. That's all I'm really worried about, is just that part. So is it odd or an even? Is it symmetric about the y-axis? Is the left side of the y-axis symmetric to the right side of the y-axis? For this one. Is it symmetric left and right? No, it's not. That looks more like a cubic function than it does a quadratic function, right? It does not look like a parabola. It is not the same on the left and the right. This is odd. It's an odd function. Sine is an odd function. So let's look at the cosine graph. That was Chala. Cosine is high, axis low, axis high. I don't really care about what's happening over there though. So that means I need to bring this here. So I want to know what's happening around the y-axis. It looks like this. That's what my wave is doing. So I'm looking at the left and the right side of the y-axis. So I'm only concerned about what's happening right there. Is that symmetric about the y-axis? Do the left and the right look the same? Yeah, that's symmetric. So this is even. It looks like an upside down parabola a little bit, right? Because the left and the right side match. It's symmetric about the y-axis, so it's an even function. And then we didn't graph tangent, but I did show you a I showed you what it looked like, and I'm going to show you right now. It looks like that. And then there's a bunch of asymptotes, and then it repeats, and then asymptotes, and it repeats, and it keeps going and going. But we're only concerned about what's happening around the y-axis. And is it symmetric from left to right? No. Not symmetric from left to right. This is also an odd function. Okay, so now when we're looking at our identities, this one, sine of a negative theta equals negative sine of a positive theta. If we think of that as x's, so if I am graphing this and I have a negative x value, it gives me for this one, it gives me a negative y. But if I have a positive x, it gives me a positive y. So positive x gave me a positive output. Negative x gave me a negative output. So the negative angle is equal to the negative of the output, like it's opposite. Whereas with cosine, it's an even function. So if I go negative x, well, that one's at 0, but we'll just say here. Then it gives me this positive y. But if I do a positive x of the same amount, it's going to give me the same positive y value because it's even. It doesn't matter if my x is positive or negative. The output, or the y value, is going to be the same. So cosine of a negative angle is going to give you the same output as the cosine of a positive angle. And then the opposite is true for the odds. Tangent of a negative angle equals negative tangent of the positive angle. So to get them to be the same, basically that's saying the negative x gives me a negative value. But if I wanted to put in a positive x, it gives me this one, so I need the negative of it to be the same. So in order for it to be equal, it has to be the negative of what I would get for the positive side. Saying negative and positive, I know it makes it confusing, but it's opposite. Odds are opposite, okay? Odds are opposite. That's your simple version. Odd functions are opposite. Evens are the same. Okay? Let's look at an example over that. It's not quite as bad as it seems. All right. Example. If tangent, oh, your head can't hurt yet. I haven't given you enough to hurt your head. Give me a minute. Just give me a minute. It's not a physical threat. Of course I'm laughing. No, they're being dramatic. Find all right, so there's the problem. If tangent theta equals 1.28, find cotangent of theta minus pi over 2. All right. Let's start by saying explaining this step by step seems way more complicated than once it clicks and you get it, then it'd be like, oh, well, I get it. Why do I have to do all that work for? I know. It's just the way it is. I didn't invent it. I'm just telling y'all about it, okay? Okay. So I'm going to start this one. All right, so let's start. Where would we like to start this one? Y'all tell me, where would we like to start?
What do you mean?
Is there a clue? There's a pi over 2 in it and a minus sign, right?
Oh, I've seen that.
Well, close.
Does it?
What'd you say? No. But, okay, so your clue on where, so when you don't know where to begin, get out your formula sheet. Look at your formula sheet and look at your problem. Does anything look similar? This right here looks like one of the formulas, right? A cofunction formula. Doesn't that kind of look like cofunction? Not exactly. We're going to need to do some stuff to it. But it's a good place to start. So I'm going to start by writing out my cofunction identity. The cofunction identity. So I'm just going to write what that is. It is tangent theta equals cotangent pi over 2 minus theta. All right? That's the identity. Those look similar, but they're not the same. So, I'm going to mess with it. I want to be able, since that's my only lead on how to solve this problem, I want to make this look like this so I can use this function, this identity, okay? The cofunction identity. This one is, but what's wrong is these aren't in the right order, are they? So let's just start by taking this right here and let's rearrange it. Let's make this cotangent, parentheses, move the pi over, the negative is with the pi over 2, so I have to do negative pi over 2 plus theta. Okay. So that's kind of, that's closer, but it's still not the same, right? Because this is positive pi over 2, this is negative pi over 2. So what if we factor out a negative, but let's leave it inside the angle part. So let's make this cotangent, parentheses, and then negative and another set of parentheses, pi over 2 minus theta. Close the inside parentheses, close the outside. So now if this inside parentheses was our theta, it would be negative angle theta, right? So we'd have cotangent of a negative angle. Like if we do this. Look at that. So cotangent of a negative angle. Is there an even, odd, even, odd identity that looks kind of like, if maybe it's not this, but maybe that was just like your x or something? We'll call it, I'm going to write that down. Cotangent of negative x. I'm saying that this in here is x. Right? That makes sense. Do I have an identity that looks like that? Yeah. Well, on the, I didn't write it down on the notes, but on the formula sheet I gave you, it said cotangent negative theta equals negative cotangent theta. That was the odd even identity. Is cotangent negative theta equals negative cotangent theta. And this looks like that side, doesn't it? Doesn't it? And I'm saying that this is x. I renamed that as x. That's the x. Okay? And it looks like this. So by this identity, can't I say that this is equal to that? Those are the same, right? Okay. So I'm going to do that. So this equals negative cotangent x okay? That's my x. All right, so I was just temporarily using that x as a placeholder. But now that I've moved over to this, now I'm with this, let's put it back get rid of the x again. So now I'm taking this. This is where I'm at. So I'm at negative cotangent, but instead of x, I'm going to put back in pi over 2 minus theta. Okay, we're good? And really, all I've done is just rewrite this, right? That's all I've been doing is just rewriting this. So this is the same thing. It's equivalent. This is where I started, and this is where I am right now. And so they're the same thing. I've just been rewriting things, moving stuff around. I'm saying that those two things are equivalent to each other. And this looks an awful lot like this one. Don't we agree? But this one's negative and this one's positive. On an equation, am I allowed to turn something from positive to negative if I want to? Yeah, as long as I do both sides, right? So let's do that. Let's take this cofunction identity and let's multiply both sides by -1. So times -1 times -1. So this is now negative tangent theta equals negative cotangent pi over 2 minus theta. So I rewrote my identity by making both sides negative. And now it matches exactly. I know. So now this matches exactly, right? And it equals what? The left side, negative tan theta. Okay. Do I know what tangent theta is? I do, don't I? So, I'll put it in there. So negative and tangent theta is 1.28 equals this. And I said that this is the same as that, right? Cotangent theta minus pi over 2. And that's what I'm told to find. So I found the answer.
It was like 10 steps for like one thing. Why do I have to break it down so much? I thought we could have done this.
Yeah. And I said that at the beginning.
So like why just to make us understand how it works?
Yeah, I have to explain what the thought process is. For this problem, would you have to work all this out? Not really. If you recognize that this is backwards, so that's negative, and that tangent is odd. So if you have the tangents and you're making it backwards, then you're going to have a negative. So negative tangent equals negative angle. This is the negative angle. So negative tangent. And that's fine if you got that, but I had to show you at least once the long way. Because if I just show you the short way, then you're not going to get it.
I just made me confused. Yeah, like in the beginning I was like, yeah, okay, and then we just kept going, and I was like, what is happening right now? I have no idea what we're doing. I don't know. Like, can we do it the simple way now and be like, okay, so this is how you do it for shorthand? I don't. I'm just like confused.
Okay, the shorthand is this is almost cofunction, but it's negative because these are backwards, right? So, okay, it's like negative cofunction right here. And if it's negative, then it would equal if the angle is negative. So it's negative angle, it equals negative tangent because it's odd because it's tangent. So the negative angle is going to give you the negative tangent. The tangent was positive, so it's negative.
Yeah. So like the first time I was like, isn't it
Okay.
just negative? I just don't understand.